Hello, welcome back to video 4, part 2 of making schematics and PCBs with KiCad. This will continue our lesson on footprints. Last time we modified footprints to customize them for our own needs. This part of the video will more specifically show you how to assign footprints from existing libraries and how to look up information about components to find what footprints would best work for them. Now we're ready to assign footprint to symbol number 4, the 3904 transistor. If I scroll down looking in my libraries for transistor, it isn't there. Let me show you another way to find a footprint to use. If you go to a component supplier, parts supplier again, I'll go to Mouser.com. Just type in 3904 transistor. And as we scroll down, it's showing again a bunch of surface mount components. I don't want that. So I'll click on some of these options. Let's do a bipolar transistor. And then I'm going to select through-hole mounting style and apply that filter. As I scroll down, yeah, that looks like the transistors that I need. So I can click on one of those part numbers. It says a 3904. And if we look at the specifications, it has the package or case. It's called a TO923. So let's go back and look for a TO923 in my package or case. So here we have a package, or a bunch of package libraries. Here's a package TO, THT for through-hole technology, so I'll select that. And now I have a bunch of options for a transistor with that package design. So I can scroll down until I find a TO92. There's some. I'll select TO92. If I want to make sure it's the right one, select the View Selected Footprint and even the 3D view. And I can see that, yes, that's actually what the transistor is going to look like. So that's the right footprint for that. I'll double click on that one to select it. The next component we need to assign a footprint to is resistor 1. So if I click on that, I can go through my footprint libraries. I can just look for resistors. Here's resistor THT for through-hole technology. Gives me a bunch of different options. I don't need an array. I have axial leads. It's a 5% tolerance axial lead resistor. And I want it to lay horizontal. So I could go down here. This gives me the length, the diameter, the pitch. So maybe what I could do is look up a supplier's website, say go back to Mouser.com, type in 1K resistor. I'm going to click on the resistors, and then I can select my power rating and my resistance. I'll select for 1K ohm, and I'll do a 1/4 watt resistor, 250 milliwatts, and apply those filters. If I enlarge this picture so I can see it better, that's exactly the kind of resistor I'm looking for. So I'll click on that part number and look at the specifications. It tells me it's 1K ohm, 1/4 watt, 5% tolerance. And then it gives me my diameter, my length, so 2.4 millimeters diameter by 6.3 millimeters length. Now I should be able to assign a footprint to that. So 6.3 millimeters length by 2.4 millimeters diameter. That's a vertical one. I want a horizontal one. That would give me the right size footprint. So I will double click on that resistor to get that footprint assigned. It takes me to resistor 2. The resistor 2 will be the same exact kind, so I'm going to double click on that one. Same for resistor 3 and resistor 4. Now it takes me to my test point probes. I'll search for test point in my footprint library. It gives me different pads I could use. So each test point needs its own pad. Let's go with a 3 by 3 millimeter with a 1.5 millimeter drilled hole through that pad. Let's take a look at that one. That looks like a good test point pad to me. I'll select that one. Double click on that, and the same for the next test point pad. My last is the 555 timer IC. This time I'm going to want to look for a package. The package is a DIP package, DIP. I want an 8-pin DIP, so I'm going to scroll down. Look at a DIP 8 lead through hole mounted DIP package. Row spacing is 7.62 millimeters apart. Let's take a look at what that looks like. That looks like my standard DIP 8 package. I can even look at the 3D view. And yeah, that looks like what I want. So I will close those out and select that one. Now I've selected all of my footprints for my schematic. Again, if I want to double check, I can say select the next unlinked, and nothing is unlinked. So I'll click Apply, Save Schematic, and Continue, and OK. If I hover over any symbol, I can click F for footprint, and it should tell me which footprint field has been assigned. The library, and then the footprint. So again, it shows all of the footprints for each of my symbols. So that's how you assign footprints to each component that you're going to have on your printed circuit board. Before we finish with EE schema, I want to show you, if we zoom out, there's a place for information about this sheet if we were to print it or export it. So I want to show you how to fill that out. If you go up to File, Page Settings, click on that, then you can input information about the page settings for this sheet. I can put the issue date, a revision, I can say is 1.1. You can title the sheet. The company you're working for, if you have that, and any comments you want to lay out. Hit OK, and it populates that. I forgot to put my name as the author, so I can go back. I can put that as comment 1. And then we'll save that sheet again. Control S for save, or go up to File menu and save. Now that we've assigned footprints to every symbol, let's do another electrical rules check to make sure everything checks out. We'll run that, and it says it's finished, no errors. So now we're ready to move on to the next step, which is to create a net list. A net list is a list of all the connections between every component on the board to make sure everything's connected as it should be, so that when we go to print it, everything will work. And we'll do that in our next video on how to prepare files for printing.